and welcome to our presentation on 130 metals with additive casting. My name is John Wright, and I'll be your host today. But first, a little introduction. We are Enable Manufacturing. We are a British company based in Leicester, actively working with UK-based engineering and manufacturing businesses. Formed in 2019 with backgrounds in both the additive manufacturing and traditional casting industries, we pulled together our combined experiences with a single goal of delivering the best of both of these worlds. We achieve this by enabling the manufacture of production quality metal parts through the use of additively manufactured molds. We call this additive casting. So what exactly is additive casting? Additive casting is a blend of additive manufacturing and traditional metal casting. Additive manufacturing is used to 3D print the sacrificial molds and patterns used in metal casting, eliminating the need for tooling and all of its associated design limitations, such as draft angles, for example. Additive casting comprises of two unique processes. With additive sand casting, we use 3D printed sand molds to supplement the sand casting process. These 3D printed molds are negative impressions of the part, which metal can be poured directly into. With additive investment casting, on the other hand, we use 3D printed plastic or wax investment patterns. These are assembled onto an investment casting tree, shelled with ceramic and fired, leaving behind a negative cavity that metal can be poured directly into. Both of these processes result in a cast metal part. So what are the benefits of additive casting? Additive casting has benefits on lead time, design flexibility, material choice, range of sizes, and cost. Let's look at this in more detail with lead time. Traditional tooling in metal casting can take an extraordinary amount of time and is often measured in weeks. By 3D printing the molds and patterns, we can reduce this to days, drastically reducing the time it takes to receive a metal part. Compared to traditional casting, additive casting can see up to a 50% reduction in lead time, simply by eliminating the lengthy tooling process. While not as fast as direct metal printing, this reduction in lead time has already proven beneficial for our customers. Let's keep in mind that direct metal printing and additive casting may have different market applications, which we'll look at in more depth later on. Let's see what we can do with design flexibility. Because the molds and patterns are printed from a 3D file, there is complete design flexibility, breaking free of the constraints in traditional casting, enabling the cost-effective production of prototype components whose designs are not yet finalized, and the ability to introduce added part complexity without fearing the increase in price. Parts manufactured using additive casting can enjoy some of the flexible design benefits that additive manufacturing is renowned for. From the optimization of parts for lightweighting applications, to consolidated assemblies, reducing the number of separate components and combining them into a single part. Additive casting can also comfortably produce complex designs that would not be possible to manufacture using traditional tooling. The material choice available to the metal additive industry, while growing at an increasing rate, still has its limitations and can often result in some compromises. The nature of additive casting, on the other hand, allows us to break free of these constraints. Traditional casting has had a long history in the manufacturing world, and thanks to this, the availability of materials is wide-reaching. With over 130 metals already available as standard with our supply chain, additive casting can take advantage of the plentiful range of existing cast metals that exist in the world today. And better yet, all of these materials are already compliant with existing industrial standards, easing the certification process needed to transition parts from prototype to production. Here is a selection of the material categories that we already work with. And within each category, there exist numerous individual grades of metals. If you have a specific grade of metal in mind, we can help you source it. Additive manufacturing has excelled at producing very small parts, but larger parts are less common. Unlike additive manufacturing, additive casting has virtually no limits on size, whether the part weighs a few grams or a few tons. Our additive investment casting process is comprised of a fine and ultrafine detail process, which can be used for small and intricate parts. Our ultrafine process is particularly suited to parts with wall thicknesses down to a millimeter and can even cast fine details, such as engraved letterings and logos. Our additive sand casting process, on the other hand, can be used with parts of nearly any size. The largest additive sand casting, for example, weighs 60 tons, equivalent to the weight of 9 fully grown elephants. In a recent LinkedIn survey conducted by Enable, we found that cost is one of the main barriers towards the utilization of additive manufacturing. Additive casting can enjoy the cost-effective nature of traditional casting to enable the cost-effective production from 1 to 100,000 parts, making the transition from prototype to production that much easier. To showcase the costs, we've prepared virtual cost case studies with 2 parts. One small part, possible to produce with both additive manufacturing and traditional casting, and another that is only possible with additive manufacturing. With this part, we have a small optimized bracket made of stainless 316 that can be produced with additive casting, direct metal printing, and traditional casting. Initially, direct metal printing presents an attractive option for low volume production, but these costs can soon become unwieldy, making additive casting an attractive option once volumes begin to scale. While direct metal printing starts off with a much lower price, the savings per unit are minimal as the quantity grows. Additive casting, on the other hand, can enjoy the benefits that come with economies of scale. The tooling required for traditional casting can be a significant investment and presents a large barrier to production for many parts that are not produced in high enough volumes. It is only once volume becomes high enough that traditional casting can be seen to be a cost-effective manufacturing method. For the volumes in between, from 5 to over 500 parts for this particular example, additive casting can be a cost-effective manufacturing method. Let's look at a second part. This part was specifically chosen as one that would not be possible to manufacture without relying on additive manufacturing, as the complex nature of the part makes this impossible to produce with traditional tooling. Where the first part we looked at was small, weighing in at 1/4 of a kilogram, this part is substantially heavier at just over 2 kilograms. With this larger part, additive casting can prove a more cost-effective option at even low volume production. This can make additive casting a cost-effective option for large, complex parts that cannot be tooled traditionally. And while direct metal printing has the advantage of a short time, the cost difference as the quantity scale is clear, presenting 2 clear manufacturing options. One, where minimizing price is a priority, and another, where the priority is placed on manufacturing a part faster. The uses of additive casting are wide-reaching and have a home in many applications across all industries. As with most manufacturing methods, there are certain applications better suited to one manufacturing process over another. No single manufacturing method can be used to produce every part that there will ever be. And if we look at this chart of cost against complexity, we can see the home that additive casting fits within. When we compare this with direct metal printing, we can see an overlap. Parts with higher complexity within this overlapping region can use additive casting as a good alternative, but can also enjoy lower costs than direct metal printing. Additive casting is not a replacement of direct metal printing, however. They both have their strong suits, and both can share a piece of the pie. Ultra-complex lattice geometries, for example, are perfectly suited to direct metal printing. So where do traditional manufacturing methods appear on this scale? As we can see, casting and forming have a home at the lower end of part complexity, but can also enjoy more cost-effective part prices at this end. And similarly with direct metal printing, there is an overlap with additive casting, particularly with parts of higher complexity and higher value. Everything in between is the gap we intend to bridge. Navigating the jungle of available manufacturing methods is not an easy task. Depending on the part, all of these processes have a home in the manufacturing world and can coexist alongside each other. There are a number of designs which additive casting is not particularly suited to, from ultra-complex lattice designs and intricate internal cavities to thin-walled structures far under a millimeter thick. These sorts of parts will always have a home with direct metal printing. The following examples of additive castings, however, are where we do add value. From optimized aerospace brackets and automotive manifolds to the complex organic designs found in the arts industry, there are countless parts that can benefit from additive casting. In the aerospace industry, additive casting can enable the lightweighting of parts to help businesses reduce fuel consumption and meet efficiency targets. While the certification of additively manufactured parts can be a complex process, additive castings can use metals already approved for use within the aerospace industry, easing the approvals process and helping to bring products to the market faster. The automotive industry can enjoy the same lightweighting and certification benefits as the aerospace industry, leading to much more fuel-efficient vehicles. And thanks to the scalability of additive casting, these fuel-efficient vehicles can be transitioned from prototypes to volume production faster and much more cost-effectively. The marine sector has been largely untapped by additive manufacturing due to the size of components and the certifications required. Additive casting can offer a cost-competitive alternative to traditional manufacturing methods using existing industrial standards specialized for the marine sector. The arts industry is no stranger to additive manufacturing, and there have been many examples in the past taking advantage of the design freedom offered. Additive casting can enable the production of much larger designs with many of the same benefits, enabling artists the ability to break free from conventional methods to explore new horizons. So, which parts benefit the most from additive casting? As we saw earlier, parts should be reasonably complex to benefit from additive casting, and iterative part designs during the prototyping stage can be produced without an investment on tooling, extending up to production volumes, where each part can be individually customized without increasing cost. And if you're unsure whether your part is right for additive casting, get in touch with us, and we'll help point you in the right direction. Thank you for your time today, and if you'd like to get in touch with us for any questions, our contact information is below. Thank you.